Welcome back. This is statistics part 4, which is histogram. The topic is histogram. This is Further Solutions Academy. Further Solutions Academy. Encourage us more by number one, help us to share our video and also subscribe to our channel. Help us to share and subscribe to. This is very important to us. Once again, Further Solutions Academy. Now, outline of this video, number one, definition of what? Histogram. I'm working on histogram. Definition of histogram, class boundaries, frequency polygon, and cumulative frequency curve. Okay, so supposed to cumulative frequency curve. There's a mistake there. Cumulative frequency curve. Okay, curve. Now, cumulative frequency curve. Okay, at the end of this video, you should be able to understand all this. Very, very important. This cumulative frequency, I think under it, which is going to be, I'm working on part 5. We'll be working on about what is it? quarter range, the side, and the center, and another. But this is part 5. I will really work on this cumulative frequency and the use of it. Now, but majorly, I will be focusing on this definition, class boundary, frequency polygon, and I will introduce this, not deep of it. Now, if I'm talking about histogram, let me stop there. Histogram. My histogram is a equal is a bar have no space between them. Is a bar that has no space in between them. It must be also equal weight because it's going to be in the graph. It must be equal weight. It must be equal weight. Now, this is a very good example of histogram. This is the frequency. This is my what? Mark. What's the class boundary? Class boundary. Now, but how do I achieve this class boundary? That is all. This is how it looked like. How can I achieve this? Okay. It's an equal bar that has no space in between them. Okay. Now, to get my class boundary, because we can't use class limit or class mark for histogram, it always be what? It must be what? Class boundary against what? Frequency against class boundary. For instance, if I have this type of this is the mark, I will have my mark like this. I will have my frequency like this. Now, this is a question. I have my class mark is 20 to 29. I have 30 to 39. I have 40 to 49. I have 50 to 59. 60 to 69. Let me stop it. Okay, I have frequency of my, I have 2, I have 8. Okay, I have this, I have 8, I have 14, I have under 14, and I have 28. Let me increase this. I have, let me increase 70 to 79, 80 to 89. Okay. And I have 10, I have 4. Now, that is my, and I want to plot my, I want to use this for my histogram. I can use this class mark for histogram is because of what? There is no continuity. There is break 20 to 39, 32. Now it means it does not continue. How do I make it continue? I will now create my what? Class boundary. Now, how do I get my class boundary? I will minus R for the upper class, lower class limit. I will now minus 0.5 from it. That will be 19.5 to add half to this place, which is going to be what? 29.5. And also here, I will minus from here. I will have 29.5 to 39.5. Also, I'll be minusing half from here, and which I'll be adding half to what? To each of these, which I'll be having 39.5 to 49.5. Also 49.5 to 59.5. Also 59.5 to 69.5. And this also will be having 69.5 to 79.5. 79.5 to 89.5. Now, this side is known as upper class boundary. This side is known as what? Lower class boundary. This one is called upper class boundary. Now, that is very, very important. Now, since I have this, if I want to, I can generate my cumulative frequency. It's good to enjoy to have that. Now, my cumulative frequency, it always equals to, this is called cumulative frequency. I'll be having 2, I'll be having 10, I'll be having 24. 24 plus, that will be 38. And I'll be having 28 and 38. That will be 6. I'll put 1 down. That'll be 5. That'll be 66. I'll be having 66 plus 10, 76, and what? 80. It means some of my frequency is what? Is 80. Now, what I want to achieve here is I can achieve my bar charts. I can also achieve my class boundary. Now, how do I achieve my histogram? I want to achieve my histogram. Now, my histogram, I will use this to also for my polygon. Okay. Now, this is my frequency, and this is my what? Class boundary. That class boundary is very important. There's no way we talk about histogram that we neglect class boundary because of what? Frequency against class boundary. Now, this thing will be in your graph. This, just like a sketch, I'm sketching here to show how to illustrate how it's going to be. Now, it will be in your graph. Your graph, you have to have scale. It's very important. Scale both on your what? Frequency axis and your what? Class boundary axis. So that when you have your scale, it will give you equal width. That is very important. But this time around, I'm just to sketch to show how it's going to be. Now, with the help of my scale, I'm working against this, and what? And this. Now, my class boundary is start from what? From 19. This can be my 19.5, followed by what? 29.5, followed by what? 39.5, followed by what? 49.5, followed by what? 59.5. We have 39, followed by 69.5, followed by 79.5, followed by 89.5. Now, can you see that the thing is what? Is continuous. My frequency, the highest frequency is 28. Now, when I'm to choose my scale for my y, for my f axis, for my frequency axis, now I must take a value that all this number will be what? In between. It will be inside of it. Which is, now if I can make a scale of 2 centimeter represent 1 unit, depending on the graph you are using. But if I make my own of what? Of 1, 2, 3, 4, 5, 6. I think successfully I've generated my 30. Now I'll be having 5, I'll be having 10, I'll be having 15, 20, 25, and 30. Now I think 38 is the highest, which 38 will be what? Around here. Now, since I have this, I cannot continue by having, when I'm in what? 19.5. It has only 2. This is 1, 2, 3, 4, 5. Now, it means my 2 will be around here. Now, that is number 1. Number 2, when I'm in what? I'm in the second one, which is 29. I'm in what? 8. My 8 is around here. 5, 6, 7, 8. Now, it must also be my what? 8. This is going to be my 8. Sorry, it's going to be inside graph. This is just sketching to show how it's going to look like. Now, with the help of your graph, it will make it neater and having a what? Equal bar. Now, if when I'm in what? 39, I'm in 14. My 14 is around here. 11, 12, 13, 14. Okay, 11, 12, 13, 14. Now, my 14 will be around here. Very, very important. With the help of our graph, it will be achieved. Now, this is my 14. When also I'm in the other side, it's also in 14. It means when it's 39, this is in 14. Now, I'm also in 14. Okay. I'm also in 14, which is 59. My 59.5 is now in what? 28. This is 25, 26, 27, 28. It means I'll be having something like this, 28. Now, 28. Now, when is in 69 is in 10. Now, this is going to be my 10. 10. Now, 10. It means I'll be having 10. Now, to what? 69 to 79, which is going to be 10. Now, when is in 79 to 89 is in what? Is in 79.5 to 89.5 is in 4. It means that my 4 will be below 5. This is my successfully, this is my histogram. This is my histogram. This is my histogram. Now I've achieved my histogram with the help of what? Class boundary. Don't forget our class boundary is always generated what? Taking out from what? Lower class limits. If you take out from it, it means 20 minus what? 0.5. This one will generate a what? Lower class boundary. And also, we have 29 plus what? 0.5. This one will generate what? Upper class boundary. Please take note of that. That is how, because the class boundary is very, very important. If you are using class mark, which is class limit, it will be in bar chart. It will be in bar chart because the bar will not be continuous. Now, example of this thing to a real life, when we're talking about portion of land, when you have to share a portion of land, now my plot of land, where my plot of land end, somebody X take over. That is continuous. That is very good example of that. Now, let me now use this opportunity to explain what is called frequency polygon. Now, let me explain what is called my frequency polygon. Now, if I'm talking about polygon, my polygon is middle of the bar, the center of each bar, the center of each bar, the center, and the center. Now, I will now make a particular like this, joining them like this, like this. Sorry, this is sketch. Inside graph, it will be better. Sorry for further solution that are still coming up to that level. I'll be teaching with an instructional material. Instructional aids. Aid. Instructional aids. Now, I'll also move on to this, and that's all. Now, by so doing this, this is called frequency, let me spell it finish. Polygon. This is called frequency polygon. And okay, that is all about on that. I think I've explained class boundary, I've explained frequency polygon. Now let me now talk about OGIF. We call it OGIF, cumulative frequency graph. Now I want to use this table. This is how this thing look like. I want to use this particular table to achieve my what? My OGIF, which is called cumulative frequency graph. Yes. Now, how do I achieve my OGIF? My OGIF is achieved by what? By cumulative frequency graph against what? Upper class boundary. Against upper class boundary. Now, if I'm talking about OGIF, now if I want to use this to achieve my OGIF, we call it, now I think you know the meaning of frequency polygon now. Now, if I want to use this to achieve my OGIF, we achieve my OGIF by using upper class boundary. This is my upper class boundary against what? Cumulative frequency. Now, the highest is 80 and the lowest is what? Now, I will now move on by this line by having, okay, I'm still on OGIF. Sorry, let me, OGIF. Let's call it cumulative frequency graph. It's very important. Now, There will be a scale, it's very, very important, and I will be using my what? Upper class boundary. My upper class boundary. This axis will be upper class boundary. Sorry, class boundary. Upper class boundary. Now, why this one will be cumulative frequency? Cumulative frequency. Now, if the highest is 80, the lowest is 2. Now, in choosing my scale, you have to consider those numbers because everything must be there. And also choosing scale here, everything must be there also. Now, it's very, very important. Now, it means these numbers are not relevant at this point. Their frequency. Now, if I should use my, it means I'll be having 10, I'll be having 20 because I'm running to 80. I'll be having 30. I'm adding to, which is not even enough for me to. If I make it 20, I'll be having 30. 40. I'll be having 60. I'll be having 80. And I'll be having 100. I think it's okay like this. It means from here to here is 20. Now, my class boundary, which is I'll be using upper class boundary, I'll be having 29.5. I'll be having 39.5. I'll be having 49.5. I'll be having 59.5. 49, 59. I'll be having 69.5. 79.5. 89.5. Now, since I have this, now I can now move on by having, I want to have my cumulative frequency curve, which is called OGIF. Now, the first one, when I'm in what? Upper class of 2, 29.5 is in what? Is in 2. It means my 2 will be somewhere here. Half of this is 10. Now, half of this is 10. It means my 2 will be somewhere here. Sorry, this is sketch. It will be plot inside what? Graph. To be plot. I'm just showing how it will look like. Now, when it's 39.5, is in what? Is in 10. It means my 10 will be around here. It's a sketch. Now, when is in 49, is in 24. I have 24. 24, it will be around here. Sorry, it's a sketch, not a plot. I'm not plotting, I'm just sketching. Sorry. When is in 49, sorry, 39, 29 is in 9, 49, okay, 50, 59 is in 38. 38 will be around here. It's very close to 40, but not 40. When is 69 is in 66. 66 is above 40. It's above 60 to be around here. It's a sketch, not, I'm just sketching. When is in that will be 69. 79 is in what? 76. I have 76. 76 will be around, sorry, it should be down, should be around here. Now, when is in 89.9 is in 80. now, which is going to be now 8. Now, I will now take my what? The curve. As if we are plotting our quadratic curve. Now, this is called cumulative frequency curve, or we call it OGIF. OGIF. Now, maybe our next video, there are a lot of things we can achieve here. We can achieve our quarter range, semi-quarter range, can achieve our dicelt and paracet, and so on and so forth. When we get to next video, we will explain that. But this is how to achieve that. Now, my OGIF is achieved, OGIF curve is achieved by what? Class boundary, and against, let me just say against what? Cumulative frequency. Against, not frequency. There's no between cumulative frequency. This is a frequency. Why this is a what? Cumulative frequency. Please take note of that. That is how to achieve our OGIF. You can ask to plot this thing in any given exam. Now, the histogram and OGIF, because both of them make use of what? Class boundary, they are a bit, that is why I did not rub this particular table, and which is I use the upper boundary to achieve my what? OGIF. Once again, this is Further Solutions Academy. Further Solutions Academy. Encourage us more. And number one, help us to share our video and also subscribe to our channel. Help us to share and subscribe to our channel. Thanks for watching.